Hi, Doctor. This is our project on DAST valuation using ZAP and DVWA done for the Security Software Engineering course. Our group members are Yang Qingxin, Zhao Yijia, Xu Junhan, and Hua Daoyang. The first part is project introduction and objectives. As we all know, web applications are becoming more complex, and with that comes a rising number of cyber attacks. That's why web security is more important now than ever before. In this project, we aim to improve our hands-on skill in application security by using industrial standard tools. Specifically, we choose a damn vulnerable web application or DVWA as our testing platform and use OWASP-Zap, a powerful desk tool to simulate real-world attacks. Through this, we were able to discover common vulnerabilities and come up with meaningful security recommendations. Here are the key objectives of our project. First, we wanted to understand how DAS tools work, not just in theory, but how to set them up and apply them in real web security testing. Second, we applied OWASP Zap to test the DVWA system, simulating real-world attack scenarios. Third, we analyzed the discovered vulnerabilities and classified them using CVE and CWE standards, which helps ensure consistency and reliability in our findings. And finally, we proposed mitigation strategies to improve secure and development practice and support future DevOps integration. Now let's talk about the scope and test environment of our project. Our testing focuses on vulnerabilities identified through DAST, both automated and manual. Also, we limited our evaluation to the external-facing runtime of DVWA, so it's black box testing only. For the test environment, we used OWASP Zap as our main tool, targeting the then vulnerable web application. DVWA was deployed using its official Docker image to ensure an easy and reproducible setup.
Hi doctor, I am Jun Han. So my part is discuss about selection of tool. So first is the what is DAST. So DAST is a type of black box security testing. That means it simulates how an external attacker would interact with our application without knowing the internal code. It works by sending QoF HTTP or HTTPS requests to run a running application and analyzing the response to detect vulnerability like SQL injection, SSS, and more. To perform DAST, one of the most popular tools is OWASP JET, which stands for Jet Attack Proxy. It is a free and open source tool developed by the OWASP community and is widely used by security professionals and developers. Jet supports both automated and manual testing. It has a spider to crawl our website and an active scanner to test for the vulnerability. It also has a passive scanner to analyze traffic without modifying it, which is great for low-risk environment. With that, we can also manually intercept and modify requests, simulate authenticated user session, and even test WebSocket and REST API. Why we choosing Jet? This is because Jet had many key features. So one of the key features is the automated scanning using Spider and active scan module. Second is the manual testing with full control over HTTP or HTTPS requests. Next is the authentication support. It is useful for testing user specific area. So other than that, it also got the CI or CD integration, which allow Jet to be part for DDoS pipeline through the Docker API and scripting. Lastly, customize report that highlight risk and provide external redemption step. Last is the integration of Jet into SDLC. So integrating Jet into the secure software development life cycle SSDLC is crucial. By running Jet scan during development staging or CI or CD build, we can catch security issue early before the vulnerability reach product. This proactive approach improves code quality, reduce long-term risk, and align with modern DevSecOps ops practice where security is integrated at every stage of the software life cycle.
Now, I believe that you have set up the environment Kali already, and let's do some process of the penetration testing. And first, we need to deploy the DVWE on the target machine. We open the terminal in Kali or Windows and run the following Docker command. This command Docker run name DVWE, and after the container starts, we go to the browser and visit uh, this uh, this command HTTP localhost 8081. This completes the initial DBWE setup, and then and next we open Zap on the attacking machine, and we configure the proxy setting as follows: IP 127.0.1 port is 8080. Then we go to browser settings and router or HTTP traffic through this proxy. And after that, we configure authentication in that. Go to the context, create a new context, and set the login URL to HTTP 192.168. You need to use your own website location and choose from the based authentication and enter the credentials. The username is admin and the password is type password. And that can now scan the website as a logged in user. Now we start the testing process. Step one, use the Spider model in Zap to create the DBWA application. Click Spider, choose the target URL, and let it map all pages. And step two, once the spider finishes, run the activity scan and select the scanned site from the left panel. Right click and choose attack and attack scan. And Zap will now inject automated payloads to find vulnerabilities. And step three is for deeper analysis. We perform the manual testing In the history tab, we select individual requests, modify them, and resend with customs payloads. And step four, we monitor serve responses, and especially looking for signs for char SQL injection or other abnormal behaviors. Also, make sure the DBWA security levels is set to low, so vulnerabilities are easier to detect. And that's all.
In this part, I will share what we found during our testing and what we learned. I start our group test with the spy scan to find all the pages in DVWA. We use the active scan to send the text payload and test the vulnerability like the TSS secure injection. We also set dividend to low security to make sure all vulnerability could be found easily. I found the test vulnerability in the test page of DWA. The site didn't clear the user input, so we could run JavaScript like script alert one and so script this should pop up. In the SQL injection module, we find the search variable that use the user to import directly in this SQL query. We use the attack payload. Were able to bypass logging and get hidden data. This shows the dangers of not using queries. In the file upload page, we upload take a web shell. We take a web shell. The site didn't check the file tab, so we could upload it and run the system command like who am I. This happened because the site allowed and the file type didn't protect the upload file or folder. This table shows three main problem we found. For each one, we list the CWRD risk level and the service goal. Fix this issue is very more important for keeping web application safe. This project help us understand how to use DST tool like that to find the real vulnerability in web application. We use both automated and manual testing. We learned that logging while scanning is important. Some vulnerability only appear after login. We also saw they need to put tools like DST tools, like that into CI/CD pipeline to catch problem early. Overall, this hands-on experience improve our understanding of secure coding and testing in real world and real life. Okay, that's all. Thank you.